sixth grade lesson. 8.2 is writing equations. Again, this is the chance to translate from words to math-ese without any stress of having to calculate anything yet. So it's just going to let your brain focus on translation. So you're going to be translating out from a word problem into an equation where there's an unknown value. And this is weird at first, but it becomes easy and you get good at it because you practice it a lot in the 6th grade, in the 7th grade, and in the 8th grade. They're all doing this right now. 7th grade, 8th grade are all doing this right now too. A little more complexity, but you learn the little easier version of it now and you build on it. So let's get you into this. So on the unlock the problem, they give us this word problem, and we still use our same steps where we read the problem, we underline the questions, circle the information they provided us, and draw the picture. And drawing in this will be pretty helpful a lot of times. So I have a circus recently spent $1,650 on new trapezes. The trapezes cost $275 for each one. Write an equation that could be used to find the number of trapezes T that the circus bought. So let's underline, they want us to write an equation to determine how many trapezes they bought. Information that they gave us, they spent a total of $1,650, and the cost of one trapeze is $275. So I generally will look for the total, and let's draw the picture. I'm going to just put in a box the total amount of money that was spent, $1,650. Then if they bought one trapeze, that takes $275 out, and then another one takes $275 out, and so on and so on. So my brain can wrap around what's happening. To write my equation, the first thing I try to figure out is, do I know the total amount of something? That's the first thing I look for, and I do. It's $1,650 that was spent. The other thing I ask myself is, what is the unknown value that I'm trying to find? And they usually give that to you in the last sentence. Sometimes they'll tell you what variable to give it. Sometimes you get to choose. So a lot of times you'll see me write at the bottom, or I'll tell you guys right at the bottom. This case, they gave us the variable T equal the number of trapezes. I put that usually on paper to tell my brain I'm going to let that letter represent what it is. That way at the end of the problem I know what it's representing, and so I know what I can make sure it makes sense. So T is not representing the cost of the trapezes. We already know that. T is the unknown about how many trapezes we bought. So do we know how much? Well, I'm going to start with the total cost because that's what I always do. I know the total cost was $1,650. So I'm going to put this over here, $1,650. And I know that the cost for each trapeze is $275. That's for one trapeze. If I buy another one, that's another $275. If I buy another one, it's another $275. If I buy another one, it's another $275. And by now you've heard me say enough times that anytime you have repeated addition, that is multiplication. I don't know how many trapezes I'm buying. That is what we decided T would represent. And that's all they want you to do right now. They don't want you to solve that. You could, if you wanted to. There's enough information there for you to solve it, but that's not what we're doing today. So an equation that could be used to find the number of trapezes T is 275 times T. You could just write that as 275T equals 1,650. That's all the answer they want there. Okay, same steps. Here we go again. Let's read it. Ben is making a recipe for salsa that calls for 3.5 cups of tomatoes. He chops 4 tomatoes, which fills 2.25 cups. Write an equation that could be used to find out how many more cups C Ben needs. Okay, underline the question. They want us to write an equation. We don't even have to solve it. We just have to write it. The unknown that we're looking for is how many more cups. So let C equal the number of cups more that he needs. Circle information they gave us. Well, in total, he needs 3.5 cups of chopped tomatoes. We know he chopped up 4 tomatoes, and that gave him 2.25 cups. So if I'm going to draw my measuring cup, he got 2.25 cups out of 4 tomatoes that he put in there. They want to know how much more he needs to get the 3.5 cups of cut tomatoes that he needs. So this is my C that's left. In this case, they gave me a number here that I didn't need. This is not a number I need this for, so I can cross it off. What I need to know is he has this many, he needs this much more in order to get all of this. And you're probably already seeing, just in the picture alone, this equation start to form. These two together, added together, will equal this as a total. So the cups that he's already filled is 2 1/4, right here. The total he needs is 3 1/2. We add that together, this 2 1/4 together with the cups that we need, C. And there's our equation. 2 1/4 plus C equals 3 1/2. And that's it. They don't want you to solve it. There is enough information there for you to solve it, but that's not your job today. So that's all they're looking for. And so when we drew the picture, that's when I realized this was a piece of information that didn't end up being important. And it took me a moment. I put this there because they gave it to me. And then when I look at what they're asking me, oh, they just want to know how much together to fill this. And then it kind of fell into place that that was not necessary right now for this question. Maybe they'll ask me something later in a follow-up question and that becomes a factor. But for now, that's not the piece of information that's needed. Okay, and so then this next couple of examples is really just getting, our brain wants to separate English from math, and when we try to put it together, our brain likes to resist us a little bit. But just let your brain work on getting comfortable with it. This lesson isn't asking you to calculate anything, it's just saying, you know what, just get your brain comfortable with this, with the translation. So we have 6 fewer than a number, we don't know what the number is 4633. So 4633 is our total, and 6 fewer than that, so if I take that unknown number and I take 6 away from it, so let's do subtract 6 from whatever that unknown number is, and they said let n represent the unknown number. So we will say n, whatever n is, 6 fewer than that, subtract 6 from it, will give you 4633. Let's look at the next one. 2/3 of the cost, and you'll probably start getting comfortable with of usually being a multiply scenario. 2/3 of the cost of the sweater is $18. Is 18 usually is a equal word. 18 is our total. The piece of information we don't know is the cost of the sweater, so let's let C represent the cost of the sweater. And we're doing 2/3 of, or 2/3 times that cost of the sweater. So 2/3 times the cost. This can also be written as 2/3 C equals 18, because remember, when your coefficient is right next to your variable, it's assumed to multiply. So you don't always have to put that multiply sign like that. What if we have to do it in reverse? Write 2-word sentences for the equation. The blank of A and 15, well, addition is the sum. Let's use the word sum. The sum of A and 15 equals, so we're just using the words we would use to say those. Or we could say, if we have a number and we're giving it 15 more, we could say 15 more than a 15 more than A equals 24, or is 24. Over here we have division going on, so words like quotient or equally split, shared. So the quotient of R and 0.2, quotient equals 40. Or the way you would just say it if you read it, R divided by 0.2 equals 40. R divided by 0.2 equals or is 40. That's all this really is. It's just getting the words with the mathies put together. So you've got this. Go ahead and tackle it. I believe you've got this.